So thanks to iDAC for curating the session, and it's always a pleasure being a part of the Facade Pavilion. And yeah, it's always good to showcase what we're doing. I run a small studio called RATLab Studio, which stands for Research in Architecture and Technology. We started back in 2012 in London, and I was working with Zahadi the architects, worked with a robotics company, moved to California, moved my way back to India after that in 2015, only to realize that nobody knows what parametric means, which is where our journey essentially started, to start to educate people about it. But that is one part of our studio, what we do. The core part of what we do is the studio, what we run. And a major vertical of the studio is doing a lot of parametric facades, which we've been doing over the last few years, last many years now, I would say. And yeah, this is something I always face as a technologist. We fail with simple technologies like these. Yeah. Yeah, okay. All right, so a plethora of works we've been doing, across different scales and typologies. Been involved in doing parametric design for installations, exhibitions, retail, commercial. But the main core value that we're trying to bring into a lot of projects is doing parametric facades and ensuring that how we can use this to create cost-effective solutions. Now, that cost-effectiveness has always been a challenge. Of course, when we started off, we realized, okay, there are no vendors, there are no contractors, there are no structural consultants to support the ideas that we were trying to develop using computational design, which is where it started to become a little challenging. Over the next few years, we worked on a lot of facade projects. Sorry, it's going back. So yeah, I mean, this will give you a sense of visual glimpse. I'm just going to quickly go through a few projects and then maybe talk a bit in detail about two projects, which are ongoing projects of ours. So again, like we have been designing projects of different scales, typologies, I mentioned, commercial projects, high rises as well. A lot of times, those projects may not have led to the execution stage for a lot of logistic challenges that we understood in the industry. And that's pretty much where our journey started, to set up an execution firm in parallel, which happened like about 3 years back. And we set up an entire factory with CNC machines, bending machines, all sorts of tools, where we can customize a lot of aspects of the facade, so that we don't have to rely on external contractors. And so far, we've been just developing that. That's more of work in progress, I would say. But that is really helping us reach cost effectiveness, I would say. So these are various projects. This one's in Tokyo, that's one in South India, close to Chennai. This is in Hyderabad. This one is in Delhi. This is in Gurgaon. Plenty of others been going on. This is one of the ongoing projects. When we talk of facades, most of the times when we think of parametric facades, we always think of, okay, where can you have parametric facades? And it's usually like a building which requires an interesting iconic structure or some sort of a frontage. So it's mostly playing with the retail or the commercial segment. We sort of started to see that as a challenge, that why can't we implement the ideology into simple, small-scale residential projects as well? Because we were having a lot of residential projects at that time, and we thought, okay, let's start to explore that in very simple ways. So this was one of the ongoing projects that we are working on. It's a residence in Sonipat, about 80 kilometers from Delhi, where, it's a very simple house in a rural development, I would say, not even urban, but they wanted to bring in a more contemporary structure. So we thought of like giving this, double height structure with a very interesting curve that we had to build. And we were relying on very, very local contractors. So we had to make sure that whatever we are doing structurally needs to be stable. Our consultant should be able to work out the structure and should be able to build by a local contractor, which is what is ongoing right now, about to finish up soon. This is another residential project we're doing right now. Again, a very simple orthogonal project, but one unique feature of the project is the facade. So we started to have a folded plate system, which we are casting in concrete as a single element. And multiple of those are put together to create this variation differentiated facade, which becomes the main highlight element of the living area and the facade area. and then the staircase behind, and this is how it looks like when it's dark. So going to the commercial scale, a little larger scale, this is one of the ongoing, recently completed project, I would say, in Gurgaon, which is a simple commercial tower, where we wanted to bring in the branding and the identity of the brand into the facade, yet keeping it very, very cost effective. So the client was very resistant that, okay, we're not going to do something extravagantly flashy or iconic. The project is visible from the main highway in Delhi. But they wanted some sort of an iconic language. So, I mean, the brand name is Akaya One, which is one of the developers. So we sort of brought in this A as one of the icon in the project. So at the corner level, you sort of see this A as the brand language, which sort of comes across in a very, very simple and constrained project, I would say. Because again, there's not much we could play around in terms of the iconicity, I would say. These are the recent pictures. The project is finished and about to open up to the public as well. This is again an ongoing project. It's a commercial center we are designing in Rewari, again about 100 kilometers from Delhi. Again, an upcoming tier B city, I would say, which is becoming more and more urban. A lot of urban brands are coming up. So we wanted to make a facade which can be made in a simple, cost-effective manner. So we played around with fins, some of which, about 30% or 20% of the fins, I would say, are curvilinear and simple straight extrusions, not a double curved structure, which is difficult to sort of manage. And then we are able to create a differentiation and create this facade in a very simple manner. And this is a SEO. They're going to be separate plots. We're setting up the facade guidelines for each plot to follow so that whatever they build, it's going to align together as a cohesive element. This is how it looks like. The landscape is also integrated with the facade in the similar language. And this is under construction right now. Hopefully it should open up in the next couple of years. The two main projects I want to talk about, which are sort of in execution stage right now, which is executed by our execution firm. One is the differential facets in New Delhi. It's a commercial building where and I remember, unfortunately, I think we presented a lot of the ideas of this project when it was started last year at iDAC as well. This was the option which later got finalized, and we're building that now. And the whole idea was to, again, the first parameter, obviously, any client gives you, and whoever is working professionally would know that it has to be cost effective. So the cost effectiveness obviously became the first criteria of the design. Second thing, they wanted some sort of an iconicity. They wanted to sort of build a landmark, which is sort of visible. There is the Delhi Metro goes right in front of this project. So it will have a very, very high visibility. So they wanted to stand out, but keeping it cost effective. That's a challenge I think most of the designers get. And so we came up with the solution of creating this differentiation where there is some sort of a modularity, there is some sort of a repetition that happens. But at the same time, there is a very interesting facade where we can we played around with a number of materials over here. This is the sort of axonometric of the facade with different layers. So there is a simple single glaze unit, glass system behind. Then we have an MS structure, which is CNC cut into profiles, welded to make the fins. And then there's an expanded mesh in the middle, which you see as a jalis behind to get the light inside. This is actually a south-facing facade, which was a very big, challenging aspect for a commercial building because they didn't want a lot of sunlight or direct sunlight, I would say, to come into the the different floors. So it's differentiated in a manner that different floors receive sort of a diffuse light inside. And we obviously had to run through a lot of analysis. When it comes to materiality, I mean, we worked with a mix of MS sheets, which are CNC cut, then ACP sheets and ACP strips coming in as the main element, and then expanded mesh. Expanded mesh is a very, very low-cost solution that we figured out. It's typically used for railings and a lot of false ceilings as well. And we thought, why can't we use that as a facade instead of creating a typical jali system, which we have to CNC cut and becomes more expensive? Why can't we use a ready-made material, but in the way that we want? So we obviously use an expanded mesh, which sort of converts your direct sunlight into a diffuse light inside. And yeah, that's pretty much how the lighting works as well. The red lines that you see over here, that's pretty much the light. So around the evening when the lights start to lit up, that's pretty much what showcases the geometry overall. And these are the shop drawings that we make as a part of the value engineering process. So this pretty much shows different sections at different levels. So you can sort of see that all the fins have different angles at different sections. So basically each fin is not straight. It's made of straight faces, but angled, and all the faces are angled. So every single angle, every single junction is not modular. It's all customized. It's a custom angle that we're working with. So that becomes a challenge when we are getting it executed from a conventional vendor, because it becomes much more expensive than a conventional facade. So with having all the tools in the manufacturing process in place, we managed to CNC cut all the elements, get everything numbered, sequenced, assembled in the factory, brought it onto the site, and then start to assemble that. One major thing that we look into when we do the value engineering of any particular project is we look into the environmental aspects. So this being the south-facing facade, obviously we had to look at the effect of the radiation on the building, on the facade, and the daylight factor inside the buildings on the floor plates. So, I mean, we do all those analyses and sort of create an ideation to understand that how the daylight is going to go in. And with these fins being added over a conventional facade, it really became a fit solution for the building, for the function that we were looking at. So obviously, this is currently in construction right now. These are not the final photos. This is under construction photographs. So at different floors, you have different amount of light received. So you can see like all the floors have a differentiated element. So you see the language, you see the design language of the project within each floor plate as well in the office space. And that brings in a lot of light because there is a jali which cuts off the direct radiation, and the light becomes a diffused light coming inside. So again, I mean, the process of construction included, of course, framing the entire. So this entire skin or the louver system had to have a framing system first, designed as per the configuration of the fins. Then we get the fins installed, then we put the jali in place, then the paint work starts to happen. Then the strips come and the ACP cladding to fill up the entire facade. So it's a very hybrid way of construction of a facade as well than a typical way how a facade is usually done. So these are again a few construction photographs, how we were testing the scale of the expanded mesh. At what scale would it work the best? And this is the current paint process happening. And you can sort of see the section. I mean, it's a very complicated section. If you have to really get it factory made through a conventional method, it becomes a very, very, it's not a cost-effective solution, ideally. So this is where using computational design and fabrication techniques comes into the picture. So we use a lot of digital fabrication techniques to, sort of make these members and again work with the local sort of fabricators as well to make things work, basically. Hopefully in the next iDAC, I will have the final presentation, final images of the project as well. So yeah, this is what it's coming out to be. It's very difficult to visualize without the scaffolding in place, but of course, we are also waiting eagerly for the scaffolding to come out and to see the actual face of the building. But yeah, pretty interesting project in its essence. One main thing that we do when we value engineer, we started to 3D print different parts of the facade. So when someone needs to understand, the fabricators need to understand different complicated junctions, the angles, what we do is we prototype at small scale. Sometimes we make physical models. At times we do a 3D printed version of the facade, which allows us to understand the different morphologies of different geometries, basically. Which becomes easier for a fabricator and the welder. Then we take these 3D prints to the factory, sit with the local fabricators, and explain them, this is the junction, this is what it looks like. That's when they start to understand, okay, this is how we need to weld, this is how we need to CNC cut, and how the parts come together to make the entire facade. This is just a snippet of the 3D printing interface, how we have to check every single aspect of it, different geometries. And yeah, eventually becomes a nice memento for the client as well to keep at the reception. So this is an ongoing one. This is a recently completed project. I don't have the final photo shoot of this, but like we have some decent pictures. So this one's called Tweening Arches. We were presented with a very, very bland building. And the challenge that we faced was we have to facelift the building to what the architects designed. And what we saw that the architects designed, we realized, okay, they have put all the budgets onto the project. It was, I think, six-story building. All the budgets were exhausted in the interiors. And they're like, okay, now we want to build the facade. We want something iconic, but we don't have the budgets. Welcome to our world. And I'm like, okay, so let's create something which we can really customize. Yet, the designer in us wanted to do something interesting. So this is what we conceptualized and which was finalized and shortlisted with the clients as well. They really wanted to facelift the brand. It's a 10-year-old company. It's into recruitment for a lot of American companies. And it's a 24 hours working office. It works in 2 shifts because they work with the American company, so they work on a night time zone as well. So they have the most of the operations happen at the night. So lighting was something very, very critical, that we want the building to be really lit up nicely. So whatever we are designing, whatever geometries we are working with, has to be nicely lit up and has to be seen at night. That's pretty much where there are 400 people working for the company walk in. So again, it was a simple building that was presented to us. So we realized, okay, we have to put, first, there were pretty ugly windows, actually, which was designed by the architects, unfortunately. It was a simple commercial project. They thought they'll just put banners outside. That would be the facade, but eventually the clients changed their mind. So we were really constrained with what we can do on the facade. We only had 3 beams at the junction of the floor slabs. We could not create a new structure. So there were a lot of challenges of that sorts. So we created this skin system where we had the glazing, then we had the fins coming in, which are done in MS. Then we had aluminum sections coming in, and then the ACP sheets like filling up the skin. So this is pretty much what it looks like, and it was the frontal part which was being covered. Again, the shop drawings which we develop in the office to make things work. And again, a major concern in this project as well was about, this was a southwest facing facade. So again, receiving a lot of radiation. So we had to understand that what is the kind of perforation level that we want to put so that the light that you get in inside is not a direct radiation. And this is what it looks like. And again, we went into 3D printing it, 3D printing in parts, understand the morphology, junctions, which is what we took forward into the execution phase of understanding every single junction, every single curve, how the consistency has to be maintained, how the numbering system of every part has to be managed. And yeah, we've been like 3D printing in different materials, colors, and all sorts of things to explore. The construction sequence has been quite interesting. Of course, we had to start with a simple glazing system. Then we had all the customized bent parts, which were like custom bent on a bending machine with some Vermas, like in the Hindi, I don't know the English word for that, but yeah, we use these Vermas to get the curve right. So those are the framework. Then get the main fins, which were in MS, getting the curvature, cladded with the ACP sheets, and both have to be cut meticulously because they have to match. One problem in the cutting or the shape of it or the bending, it will not match, and that will become a problem. An open gap in a facade can be a very big culprit. So yeah, that was pretty much the construction sequence when we got the primary fins in place. Again, cladded with the ACP sheets, so use of MS. So this is what was presented to us. This is the before and this is the after. This is the actual photograph. And we pretty much managed to go as close to the render as we designed, which is usually very challenging. But yeah, we pretty much managed that. And initially, so there were like 4 windows, and the clients, the architects that time thought, okay, they'll just put signages, and that will be the facade. And what we did was sort of a rebranding for the entire company. It's a 3,000 people firm. They have like multiple offices. And they were fairly impressed by the whole design language and the branding being recreated only through the facade. That the next few projects, hopefully, that they line up are going to be following a similar language. because we have a sort of a language being developed. That's in fact the logo of the project as well now, which you see on the top right corner, which was going with the language of what we developed. So this is pretty much what was before, this is the after. Again, the challenging part that I mentioned was a structural aspect, which usually one doesn't see. But we had a big constraint that whatever you're going to build on the facade cannot come on the ground floor. So we were not allowed for some reason to get the framework till the ground level. So there were no way we could build a second skin. So this has to be a second skin which has to be supported on the existing architectural structure that existed. So we really had to work and fight with the structural consultants to understand what is the loading that your beams can take. Accordingly, we realized, okay, we have to reduce the amount of MS, increase the amount of aluminium to make sure that the facade is lightweight as well. And yeah, and then we designed the lighting sequence because lighting was a very integral part of the project. So also I have to say that, I mean, we always prefer something very, very subdued and subtle in terms of the aesthetics. The client wanted something very, very flashy, that it should be absolutely flashy lighting. And we're like, okay, we'll give that to you as well. So we did like 6 different kind of lighting sequences. And we instructed the building management to only switch on one, which we like, and not switch on the others, except for the part when it's a Diwali time, or any kind of celebration. So, I mean, essentially, the idea was to just accentuate the geometries that we see, but we also put all the lighting inside all the elements. So everything that was custom bent also had to fit in the light, had to have the provision that the lights could be changed at any point of time, had to have the provision that all the drivers of the lights have to be at one place. So you can imagine the amount of wiring that we had to plan and synchronize with the design. So these are the challenging parts, but also the interesting parts, I would say, as a part of our work. And yeah, this is pretty much what it looks like right now. This was taken a few days back, in fact, by my team. How it sort of looks like. We yet to get a professional photo shot done of this. This is when all the lights, most of the lights are on. Of course, we prefer this one where we don't see the central fins. We only see the geometry. And yeah, I mean, it's a hybrid facade, custom curves, custom bends, 3 types of materials, and a glazing behind to hide the ugly windows that we had initially. And that became a very huge facelift. When it comes to cost effectiveness, the facade actually costed about 1/3 of a conventional facade. Even if you just put tiles on the facade, it'll cost you more than this facade. And that is where the key factor of the project was, that we could manage it in a cost-effective manner, yet create an interesting parametric facade executed right from start to end, entirely within our studio. So I think that became a very big reward for us when the final thing came up. So yeah, that's pretty much about it. Thank you so much.